Hello guys, and welcome back to my YouTube channel or the Vig Structure Hub. This is the #1 channel for structural insight and a place where you learn, build, and innovate. For those who have not subscribed to the channel, I do encourage you to subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. So today I want to tackle example number 2, and this is the prestressed concrete design. So the question is on the board and it reads, the figure below shows the section of a prestressed concrete beam of 18-meter span. If the prestressing force is 1500 kilonewton, determine Roman number 1, stress at the top and bottom of the section due to prestress. Roman number 2, combine stresses at the top and the bottom of the section due to prestress and self-weight of the beam. Take unit weight of the concrete as 24 kilonewton per meter cubic. So this is the section of the beam. As you can see, the top flange is 600 millimeter and the bottom flange is 400 millimeter. The thickness of the web is 200 millimeter and the width of the bottom flange is 450 and the height of the web is 600 millimeter and the width of the top flange is 200 millimeter. And then we have a prestressing of 1500 kilonewton and it is placed 150 millimeter from the bottom flange of this section. So let's see how we can tackle such a question. So for you to tackle this question, you first determine the properties of this section. And how do you determine the properties of this section? So the first property is the area. So you will get the total area of this section. So for you to get the total area, you will divide this section into three figures. So you will have figure 1, figure 2, and figure 3. So the area total will be the area of these respective figures, the sum of the area of these respective figures. So if we begin with the first one, we will have 600 times 200. So this is 600 times 200 plus, we come to the second one. The second one, we have 200 times 600. So 200 times 600 plus the third one will be 400 times 450. So area total is equal to so area total is 420,000. So area total (420 millimeter cubic). And then after calculating the area total, we will now proceed to what we call the Y bar. So Y top and Y bar bottom. So allow me to clean here so that we can continue with our question. So you can start with either Y top or Y bottom. So if you start with Y top, after getting Y top, you will subtract the value of Y top from the total height or depth of this section, and the result will give you y bottom. Or you can start from the bottom, and then the value for this y bottom will be subtracted from this height or depth of this section, and the result will give you y top. So I want to begin from the top. So y bar top. So y bar top. So we will start from here as we proceed to the bottom. So we start with the area and y bar of this first figure. So the area of this first figure is 200 times 600, which is 120,000. So this is 120,000 times y bar of this figure number 1, which is 200 all over 2, like that. Then plus the second figure is this one from here to here. So the area will be 200 times 600. Again, it will give us 120,000 times a half of this depth, which is 600 all over 2. Remember, we have considered our calculation from the top. So you will add 200 plus 200. Again plus, we come to this one. The area will be 400 times 450. So this is 180,000 plus 180,000 times a half of this width, which is 450 over 2, again plus 600 plus 200. After doing so, you divide everything by the total area. Then you divide, this is the larger bracket, divided by area total. So let's now carry out the operation. So the answer is equal to 256.5 times 10 to the power of 6 divided by area total. So 256.5 times 10 to the power of 6 divided by 420,000. So y bar top is equal to 610.71 millimeter. And then y bar bottom, as I said earlier, you take 450 plus 600 plus 200 minus 610.71. So this one will be 450 plus 600 plus 200 minus answer 639.29 millimeter. So our y bar bottom is 639.29 millimeter. So we can indicate on our section, as you can see, the y top the y top is smaller than the y bottom. So if we can draw our y bar top and y bar bottom, this is how it will look like. So this is the y top from here to here, which is 610.71, and from here to here is the y bottom, which is 639.29. So that is how we calculate the centroid of this section. So let's now proceed to a second moment of area. So allow me to clean here so that we can continue with our question. So I will start from here. Now to calculate Ixx, this is the second moment of area. The formula is summation of b d cubed over 12 plus I gg. So that is the formula. So Ixx will start from this figure number 1. So figure number 1 is equal to bd cubed. This is the b is 600 times d is 200. But remember 200 is cubed. So 200 is cubed like that. And then all over 12 like that, plus IgG is the area of this figure, which is 600 times 200, and you get 120,000 times you will take the y top, which is 610.71 minus a half of this width, which is 200 all over 2 square. So we are done with the first figure, and then plus. We now come to the second one, which is this one. So the BD cubed will be, the B is 200 millimeter and the D is 600 millimeters. So plus 200 times D, which is 600 cubed all over 12, plus again the area. So the area is 120, because you multiply 200 times 600, you will get 120,000. Multiply by multiply by 610.71 minus a half of 600 is 500. No, a half of 600 is 300. Then plus 200, you get 500. So minus 500 square. like that. And then plus, we come now to this, to the last one. The BD cubed is, D is 450 and B is 400. So this one is equal to 400 times 450 cubed all over 12. And then plus the area is 400 times 450, which is 400 times 450, which is 180,000. So plus 180 times you take 610.71, 610.71 minus. Now a half of 450 divided by 2, you will get 225. 225 plus 600 plus 200. So 450 divided by 2 plus 600 plus 200. So you get 1025 minus 1025 all over 2, like that. After doing so, you are done with the section, the IXX. So carry out the operation to get the value for IXX. So IXX is equal to 70.71 times 10 to the power 9 millimeter to power of 4. After calculating IXX, we now proceed to what we call section modulus. So we proceed to section modulus. So that is ZXX, ZXX or Z top. So let's start with Z top. So Z top, we will take 70.71 times 10 to the power of 9 and then divided by Y top. So let me give you the formula. IXX divided by Y bar top. So this one will be 70.71 times 10 to the power of 9. Y top is 610.71. .71 times 10 to power of 9 divided by 610.71. So this one is equal to 115.78 times 10 to power of 6, and this one is in millimeter cubic. We proceed to Z bottom. So Z bottom will be IXX over Y bar bottom. So this one will be 70 0.71 times 10 to the power of 9 divided by 639.29. So this one is equal to 639.29. 110.61 millimeter cubic. So those are the section properties of this section. So allow me to clean here. So you will say y z top is equal to 115.78 times 10 to the power of 6 millimeter cubic. And then z bottom is equal to 110.61 millimeter cubic. So now we proceed to question Roman 1. So question Roman 1, it says that determine stresses at the top and bottom of the section due to pre-stress. So determine stresses at the top and section, at the top and bottom section. It should be bottom and bottom section due to pre-stress. So we'll begin by direct stress. Direct stress, which is equal to P over A. So P over A is equal to, our P, as you can see, is 1500 kilonewton. So this is 1500, not 15, 1500 kilonewton. And you will change from kilonewton to newton. So you will multiply by 10 to the power of 3. Then divided by area. Our total area is 420. We already calculated this. And then you carry out the operation. So 1500 times 10 to the power of 3 divided by 420, 420,000. So you will get 3.57. So this one is equal to 3.57 Newton per millimeter square. And then we proceed to a stress due to pre-stressing. So stress due to pre-stressing. So this one is given by P E over Z. But since we have Z top and Z bottom, so we will begin by Z top. So P E over Z top is equal to, our P here is 1500 times 10 to the power of 3, then times eccentricity. So eccentricity, it means it is the distance away from the center of the section, and our center here is this neutral axis. So since this distance from here to here is 150, then it means this distance is equal to E. So E. So you can say E is equal to 639.29 minus 150. And the answer will be 639.29 minus 150. So the answer is 489. 89.29 millimeters. So E is equal to 489.29. So multiply by 489.29 and then divided by Z top, which is 115.78 times 10 to the power of 6. So let's punch our calculator. So the answer is 6.39 Newton per millimeter square. And then we proceed to Z PE over Z bottom. So this one will be 1500 times 10 to the power of 3 times 489.29 all over Z bottom, 110.61 times 10 to the power of 6. This one should be times 10 to the power of 6 times 10 to the power of 6, like that. So the answer is 6.64. 6.64 Newton per millimeter square. And then you can combine the two stresses, that is the direct stress and the stresses due to pre-stressing. So combining the two, combining. So let's start with the top. So we have PA, which is always positive. It will be the same for the top and bottom. And then we will come to the top fiber of this section will be in compression. So minus PE over Z top. So this one is P over A is 3.57 minus 6.39. So this one is equal to 3.57 minus 6.39. The answer is negative 2.83 Newton per millimeter square. So it's equal to negative 2.82 Newton per millimeter square. We proceed to, so this is for the top. This is for the top. And then bottom. So bottom will be P over A plus PE over Z bottom. So this one will be 3.57 plus 6.64. So this one will give us 3.57 plus 6.64. This is 10.21 Newton per millimeter square. So we are done with the first part of the question. We now proceed to the second part of this question. So allow me to clean also here so that we can continue with our question. So let me write these stresses here. So we have P over A is equal to 3.57 Newton per millimeter square, and then PE over Z top is equal to 6.39 Newton per millimeter square. Then PE over Z bottom is equal to 6.64 Newton per millimeter square. So we now proceed to question part two of the question. So combine stresses at the top and bottom of the section due to pre-stress and self-weight of the beam. So for us to tackle question number 2, we need first to calculate the on weight of the beam. So on weight of the beam. And to calculate the on weight of the beam, remember the area for this section, it was 400, or it is 420. So area is equal to 420,000 millimeter square. And remember, we have been given the unit weight of the concrete as 24 kilonewton per meter cubic. So you can use this area to calculate the on weight of this beam. So this how it will be. So loading, or the on weight of the beam, is equal to 420 all over, or times 10 to power of negative 6. Why 10 to power of negative 6? Because we are changing from millimeter square to meters square. So 1,000 millimeter is equal to 1 meter. So if you square 1,000, you will get 10 to power of 6 times the density, or the unit weight, is 24. So this one will be 420,000 times 24 times 10 to power of negative 6. So 10.08. 10.08 kilonewton per meter. So if this is our beam, so this will be the on weight of this beam, which is 10.08 kilonewton per meter. And remember, the span of the beam from the equation is 18 meters. So M maximum, or maximum moment, is equal to WL square over 8. So this one will be 10.08 times length is 18 meters all over 8. So we will get 10.08 times 18. This one is supposed to be square. 18 square times 18 square over 8. So this is 408.24 kilonewton meter. And then from there, we can now calculate the stresses. So stresses due to on weight, of the beam, so this one is given by M over Z. So M over Z top and M over Z bottom. So let's begin with M over Z top is equal to, M is this 408.24 times 10 to power of negative 6. Change it from kilonewton meter to Newton millimeter. All over Z top is here 115.7 times 10 to power of 6. So 408.24 times 10 to power of 6 divided by 115.7 times 10 to power of 6. So this is 3.53 Newton per millimeter square. So this is M over Z top. M over Z top. We now proceed to M over Z bottom. So M over Z bottom. So M over Z bottom will be 408.24 times 10 to power of 6 over Z bottom, which is 110.61 times 10 to power of 6. Yes, times 10 to power of 6. So this one is equal to 3.69 Newton per millimeter square. After doing so, we now combine all the three stresses. So this is for Z top. Let me write it here. M over Z top is equal to 5.53 Newton per millimeter square. Now combining the three, because you have been told combine stresses at the top and bottom of the section due to pre-stress and self-weight of the beam. Now combining all stresses. So we will begin by the top. At the top, we have PA, which is positive. Then we'll come to stress due to pre-stressing. At the top, you have 6.39. So this one is negative, minus PE over Z top. And then we'll come to this one. This one will be plus M over Z top. So this one is equal to PA is 3.57 minus PE over Z top, which is 6.39 plus 5.53. So this one is equal to 3.57 minus 6.39 plus 5.53. 2.71 Newton per millimeter square. And then we'll come to the bottom. Bottom will be P over A, which is always positive, plus PE over Z top minus M over Z. Now this should be bottom. Z bottom. So this one is equal to 3.57 plus this one 6.64 minus this one 3.69, which is equal to 3.57 plus 6.64 minus 3.69. So the answer is 6.52 Newton per millimeter square. And the question ends here. So this is the end of the question, and thank you for your time. I hope the video are helping you to revise for your exams. And please share this video to your friends, comment, like, and share these videos. So we meet again in my next session, and thank you for your time.